So let's finish off our discussion of L systems by considering a few perhaps less obvious examples. All right, so one of those could be maybe a road network, right? So we might have 90-degree angles here for this road network, maybe utilizing both long segments of road and maybe shorter segments as well to start getting some interesting looking shapes, right? So this maybe we got a few short pieces there, and then a few longer pieces, and then a short piece, and then we kind of terminate right there, right? So perhaps this could be a branch from the L system. Again, going back to that idea of branching systems, we may return to the original, the originally saved location here, and maybe continue on a little bit. Maybe this part branches out, makes some turns, and continues forward. So now I'm just drawing this out to get the general idea of, the sort of shapes I want to make, and then this would have to be generalized back to an L system, something which utilizes branching, something which utilizes different lengths of line segments. Something that only generally has branches lasting for a certain length, right? So we'd have to do a bit of work here and take this idea and turn it into an L system. However, by just drawing it out, we can explore, the sort of L system we want to create. Another idea, which is maybe a bit more obscure or difficult to understand until we draw it out, would maybe be designing city blocks for maybe a procedurally generated city. So we could start with a few city blocks here. Let's just put a few of these city blocks side by side. And then we could have our L system perform a few different operations, such as perhaps A is divide the city block vertically. Maybe B is divide horizontally. Maybe C is maybe a uniform subdivision. A uniform subdivision, both horizontally and vertically. And perhaps D is move on to the next city block. So here's an idea of how this idea for a city block generator might work. Right? We could draw out a few. I'm just going to randomly pick some characters here and see what we get just by following these very simple rules. Let's see what we get here. All right, so starting off on the first city block, we get an A, which we said that was a vertical subdivision, right? And another A, which is another vertical subdivision of everything, right? And then we get a B, which is a single horizontal subdivision, right? So there's one layout, again, just generated by the L system. We have a D character here, which is move on to the next block. And then we start with two C's. Remember, C was the uniform subdivision. Let's do that. So that was one uniform subdivision and another. There is our second subdivision. And then we get a D again, so we move on to maybe the next city block. And then we get an A and a B and a C. So first A, B. Oh, this is going to look like two subdivisions, A, B, and C, right? So first vertical, then horizontal. Well, I didn't think that one through, did I? A, B, and C is the uniform subdivision. So, well, we get sort of the same results here. So that would be something to keep in mind and go back and change if we were designing an L system. We get the D, which is to move on to the next block, and then we just perform an A, which is a single vertical subdivision. All right. So, I mean, hey, I made kind of a mistake here live while recording this, right? So, but that just shows you, right? If you were going to follow this approach for designing an L system, then you'd have to prototype it. You'd have to test it out and see that, oh yeah, well, if I don't want to get an A, B, and C in a row, right? Because that pretty much just is equal to 2 C's, right? So, but anyway, once you come up with a decent result for this, then you could just, position your building models inside these cells. You could consider them to be bounding boxes, right? And get different sized buildings to be positioned in there. You could easily take this and, have different quadrants, perhaps, of a city block behave in different ways. There's so many things you could do with this, just by, again, following a very simple set of production rules when building out the L system. And one last example where we could implement L systems to achieve some interesting results might be using an animation state system and having that just execute a series of predefined animations. So animation state systems are widely used in game development, and maybe you could use something like this to maybe randomly using an L system. Maybe an F is a walk forward, and well, again, maybe we'll use our old symbols of plus, which is a clockwise rotation, and a minus, which is a counterclockwise rotation, and maybe an X is a pause. So again, using the idea of creating production rules and evolving an L system, we could create a complex set of instructions here. Again, maybe introducing probabilities into those production rules. And we could use these to have a character, maybe an NPC in a game, just follow these instructions, right? Maybe first they'd walk forward and then walk forward again, and then maybe make a rotation and or change heading and walk forward, and then maybe they'd pause here for a bit and then change heading again, walk forward, change heading, maybe pause again, do another walk forward, right? And again, if we introduced random probabilities into this L system, we could very easily generate a different sequence of actions for different, maybe NPCs, for example, right? So there's just another thing, another way where we could potentially use L systems.